Okay, so we are just going to spend today recapping a few of the circle theorems, just because it is the question in the assessment where most people came unstuck. So I'm just first of all going to remind you about what the circle theorems are. So the first one tells us if we've got a chord a bit like this, and then I go off from the different ends of this chord to different points on the circumference, then I know that the angles made there are all equal. So this, and this, they are all the same. All right. We say that they're in the same segment because this made here is a segment. When we go here, we're using a chord. This thing here is called a segment. All right. And the circle theorem there is angles in the same segment are equal. So as a reminder, you might need to state these theorems. In fact, just get in the habit of whenever you get these questions, you just state them automatically, regardless of if the question tells you to or not. So angles in the same segment are equal. Right, next one. So for this one, we've got a chord, and we've got an angle that's made from that chord to the centre, and one that's made from that chord to the circumference. And the theorem here is that this angle here is two lots of this. So if we label this x, this is 2x, and this is the one that people missed in the exam. People tried to use this, so they had something like this, and they went, oh, okay, well, this one here is the same as this one here. Well, no, that is not the case. All the angles here hit the circumference. This here obviously hits the centre. And I know that the questions always say that they're not drawn accurately, but realistically you can tell that is those two angles on this diagram are not the same. So the theorem here, the angle of the centre is twice the angle of the circumference, or conversely you might see the angle at the circumference is half the angle at the centre. Okay, so for this one, be very careful. If you ever see a quadrilateral that is circumscribed in a circle, please make sure you keep an eye out for this circle theorem. So this circle theorem tells us that this is called, remember, a cyclic quadrilateral. This is called a cyclic quadrilateral, and it tells you that these, like for example A and B, that A and B added together equal 180. All right, and similarly, for example, here, let's call them x and y. X and y equal 180. So if you've got this cyclic quadrilateral, so all those points hit the circumference, then the opposite angles add up to 180. So you would need to state opposite angles in a cyclic quadrilateral sum to 180. You need to get those keywords in there for all of these. You need those keywords. If you miss out opposite, you miss out cyclic, you miss out quadrilateral, you're not going to get the reasoning mark. Right, the next one. Here we have got the tangent to a circle, and if I join that up with the centre, then this angle is 90 degrees. Okay, so the theorem here is that the tangent and the radii meet at 90 degrees, or the angle between a tangent and a radius is 90 degrees, or is a right angle. So there is a little bit of variation you can get away with, but you do need to get the key information in there. So the tangent and the radii meet at 90 degrees. It doesn't matter where I draw that tangent, it's always gonna, when I draw the radius to it, it would be 90 degrees. Okay, there's a radius, and that would be 90 degrees as well. So the next one, if I have the diameter of a circle, and then I join this up to the circumference at some point, then the angle it makes is again 90 degrees. Okay, so the theorem here that you would need to state, the angle in a semicircle is 90 degrees. Sometimes you will see this stated a different way, like the angle subtended by a diameter is 90 degrees, something like that. But the best way I find to remember it, the angle in a semicircle is 90 degrees. So those are the 5 main ones we've looked at the moment. The last one, I've put another circle here because it is something that, again, people forget, and that is if you have a triangle a bit like this one, then I know straight away that this is an isosceles triangle, because obviously these two lines here and here are both radii, they go from the centre to the circumference, so therefore they must be the same length. Therefore it's an isosceles triangle. And remember, which tends to be used a bit more, it means that these two angles here, the base angles, are the same, which you could need to use. So these circle theorems you not only need to be able to apply, but you need to be able to recall as well and explain your reasons. Do not forget, when you're asked to explain your reasons, you need to give every single reason possible. For example, if you use the fact that a straight line equals 180 degrees, you have to write this down in your reasoning. You can't just assume the examiner knows it. Don't skip showing any steps, which some of you have had the tendency to do in the past. Angles in a right angle are 90 degrees. Things like that, which you think are obvious, you still need to state that you're using that fact in your working out. So just keep an eye on for this. Right, okay. If you log on to Dr. Frost and have a go at those questions. If you've already done that, then have a go at the other tasks I've set. You may like to screenshot this just so that you have it just to hand when you're answering these questions, and you've got it for posterity as well.